Number 6. If I leave it exactly like that, then the derivative would be 1 over the square root of x plus 1 and then times the derivative of the square root of x plus 1, which that would involve the chain rule, right? Okay, or is there another way that I can rewrite this logarithm? Good. 1/2 times the natural log of x plus 1. Everybody okay with that? All right, so then the derivative, the coefficient in front, remember with derivatives, the coefficient in front just doesn't change. And then I'm going to do 1 over the argument, which would be 1 over x plus 1. And then what's the derivative of x plus 1? 1, which you obviously don't have to write, but I've stuck it there just to remind you that you do need to check and make sure that you take that derivative. If you were to not rewrite it with the 1/2 in front and you were to do 1 over the square root of x plus 1 and then times the derivative of square root of x plus 1, it would be messy, but it would simplify down into that. It's kind of weird that it would happen that way, but it's just kind of a question of whether you want to do the simplification first or last, and it's much easier to do it first. All right, number 7's got some absolute values in it. Don't let the absolute values freak you out because they're just there to kind of be, for lack of better terms, politically correct. I guess mathematically correct is the way that we should say it. But the argument of a natural log has to be positive because remember the domain of ln x is positive. So we're going to work the problem the exact same way. It's not going to throw anything off. So if it's the natural log of the natural log of cosine x, the derivative is going to be 1 over cosine x times negative sine x. Good. So you're welcome to write that as negative sine x over cosine x, or the back of the book will probably write the answer as what? Negative tan x. Good. Okay, so the question is, the answer could be negative even though there's an absolute value. Think about what we are representing. What does the derivative represent? The slope. Okay, the absolute value means you're going to just have positive y values. So, but is it conceivable that even positive y values might have a negative slope? Yes. So if you kind of think through that systematically, then it does make sense. But I can see why at first you would think, I started with an absolute value, how do I end up with a negative? So, good question. Okay, I just kind of moved the screen around because I want to have a little bit more room. Now, number 8. Using the natural log derivative rule, I could take 1 divided by this whole huge chunk, and then I would have to take the derivative of that whole huge chunk. Does anyone want to take the derivative of that thing right there? No. So what we want to do is we want to expand it using our log properties. All right, let's kind of use our general rule that anything on top is going to have a positive coefficient and anything on the bottom will have a negative coefficient. So I will have the natural log of x plus what? 2 natural log of x cubed plus 4. Good. Minus 1/2 natural log of 4x squared minus 4. Perfect. I haven't taken a derivative. I've just rewritten the problem. So I still have to write that as y equals. All right, now I can just take the derivative term by term by term. So the derivative of ln x is 1 over x plus, the next one's going to be 2 times what? One over x cubed plus 4 times 3x squared. Minus 1/2 times 1 over 4x squared minus 4 times 8x. Perfect. Now, I will warn you right now that if you try and normally, however you choose to work a problem, I will grade it, and if you've done it correctly, I will give you credit for it. But I refuse to grade that problem if you don't expand it first. Okay, so I'm just telling you right now, you'll receive no credit for trying to do 1 over that chunk times the derivative of that chunk. I won't even look at it. So make sure you expand it first. Somebody will try and do that. Okay, number 9. Number 9 would be a real pain. Notice there's no natural log here. So literally, I would just have to use which rule? The quotient rule, but the chain rule is also going to be involved. Or you could use the product rule, but the chain rule is still going to be involved. Okay, there's some serious moaning over here about that's horrible. Just like we could square both sides of an equation, you can take the natural log of both sides of an equation. So let's try that. All right, so let's expand the right side. The left side is going to be the natural log of y. The right side would be 2 natural log x plus 3 minus 1/2 natural log x squared plus 2. Okay. I'm trying to find dy dx, or the derivative of y with respect to x. So what would the derivative of natural log of y be with respect to x? 1 over y dy dx, or in this case, let's just call it dy, because it's just the derivative of y. If you want to put dy dx, that's fine. You can. All right, so 1 over y, derivative of ln y is 1 over y dy. Okay, the right side's easy. We've been doing that. That's going to be 2 over x plus 3, then times 1. Minus 1/2 times 1 over x squared plus 2 times what? 2x. Now, I'm trying to find dy dx, or I am going to go ahead and write dy dx right here instead of just dy. I'm trying to solve for dy dx. So what do I need to do to both sides? Multiply by y. So multiply both sides by y and get that dy dx equals this whole thing right here. But everything else is in terms of x. Could I rewrite y in terms of x? Yes. Go back to your original problem, and we're going to write 2 over x plus 3 minus, I'm going to do a little bit of simplification just because I'm feeling a little bit of algebraic guilt right now. X over x squared plus 2. That 2 will cancel with that 2. And then times x plus 3 squared over the square root of x squared plus 2. No, you do not have to do that, the simplification that I did up here with the 1/2 times 1 over x squared plus 2 times 2x. I do want you to put it in terms of all one variable. So I do want you to substitute that y back in. Now, that answer looks kind of long. It was a long answer, but just imagine all the work that if you had gone through the product or quotient rule along with the chain rule. I promise you that's easier. All right, last problem. Locate the relative extrema. It's been a little while since we've done this, but we're going to always keep coming back to that. What do I do first in locating the relative extrema? Define the derivative. Okay, so the derivative would be 1 over x squared plus 2x plus 3 times what? Plus 2. And then what do I do once I get the derivative? Set it equal to 0. All right, I am going to write this as a fraction, and I'm going to factor it, because anytime I'm setting something equal to 0, factoring is probably a good idea. So I'll have 2 times x plus 1 on top, and on the bottom, that doesn't factor. So that's just fine. Makes it easier. All right, so I'm setting it equal to 0, so therefore x equals what? -1. Good. Now, I'm basically finding my critical points here. And the critical points are where the first derivative equals 0 or where the first derivative is undefined. And that's why I was trying to factor the bottom of that, because I want to figure out where that derivative is or that denominator is undefined. However, we could use the quadratic formula to solve for that, but I'll tell you right now that there are no real solutions to x squared plus 2x plus 3. So I don't have to worry about where the derivative is undefined. Yeah, I mean, if this had been something that was easily factorable, then you would have to take into account where the bottom. Oh, no, I won't give you one where you'll have to use the quadratic formula to find those zeros. All right, so I have a critical point at x equals -1. How do I determine whether it's a min or a max? Okay, well, a number line, and I want to see if if the first derivative is changing positive to negative or negative to positive. So I could plug in a -2 for x. If you plug in a -2 for x, you're going to get a negative on top and a positive on the bottom, so that's negative. And if you plug in a 0 for x, you'll get positive divided by positive. So the point -1, comma, how can I find the y value? All right, plug that -1 in for x. So I would have 1 minus 2 plus 3. So the natural log of 2. So let's just call it the point -1, comma, ln2 is a relative what? Min, because f prime of x changes negative to positive.